Trojan worlds are among the most intriguing and least understood neighbors of our solar system. They travel quietly beside planets, sharing their orbital path while remaining locked in a delicate and ancient gravitational choreography. These objects occupy the legendary Lagrange points, gravitational sweet spots where the pull of the planet and the sun combine to create areas of stability. The concept itself almost feels mythical, as though the planets have hidden companions marching in step with them, unseen guardians or silent stowaways accompanying them through the vast and cold reaches of space. The existence of Trojan worlds challenges the idea of a lonely planet, because in reality, no planet orbits the sun entirely alone. Whether enormous gas giants or smaller rocky planets, many worlds have these co-orbiting partners, and they have been circling in these gravitational sanctuaries for billions of years. The most famous Trojan worlds belong to Jupiter. They are so numerous that the planet appears to shepherd two enormous swarms of asteroids, one leading Jupiter in its orbit and one trailing behind. These groups are collectively known as the Greeks and the Trojans, an astronomical naming tradition inspired by the ancient legends of the Trojan War. Yet the story unfolding among these celestial bodies is far older than any human myth. Each fragment is a frozen whisper from the earliest days of the solar system, when dust and rock collided and merged to form the larger planets. Many of these Trojan asteroids may be primordial remnants, untouched since the era when planets were still assembling. They offer a window into a time long before Earth existed in its present form. Understanding these worlds is akin to traveling backward through time and listening to the echoes of creation. Their stability at the Lagrange points is a delicate triumph of gravitational balance. Picture the Sun and Jupiter exerting their immense forces like two teams in a cosmic tug of war. At two precise places in Jupiter's orbit, the gravitational pull and the orbital momentum of the asteroids align so perfectly that the objects can remain in place indefinitely. It is a celestial equilibrium so subtle that even minor deviations could send an object spiraling away. Yet these Trojan worlds have endured for billions of years, surviving planetary migrations, collisions, and gravitational disruptions that have reshaped the solar system countless times. The fact that they persist speaks to the remarkable precision of nature's mechanics. Although Jupiter holds the largest Trojan populations, other planets host their own co-orbiting companions. Neptune possesses a growing number of known Trojans, some surprisingly stable despite the gravitational disturbances expected in that region of space. Mars has a few small Trojan bodies of its own, including one that appears to be a fragment of a much larger object shattered by ancient impacts. Even Earth has a Trojan companion, a faint and elusive asteroid named 2010 TK7 that occupies our leading Lagrange point. It is a tiny world compared to the giants near Jupiter, yet its existence confirms that even our own planet is accompanied by a silent traveler keeping pace with us on our year-long journey around the sun. The possibility that Earth might harbor more Trojan worlds has sparked considerable scientific curiosity. These objects are extremely difficult to detect because they tend to hover in regions of the sky where the sun's glare makes observations challenging. Nevertheless, astronomers continue searching, motivated by the possibility that more Earth Trojans could exist. If discovered, they might contain material older than Earth itself or offer clues about how planets acquire their final compositions. In a distant future, they could even serve as stepping stones for human exploration, habitats for scientific outposts, or reservoirs of useful minerals. Scientifically, Trojan worlds represent a treasure trove of information about the formation of planets. Many models of the early solar system predict that the giant planets migrated from their birthplaces, shifting their orbits dramatically as they interacted with the surrounding disk of dust and gas. During these migrations, vast populations of objects were scattered or captured. Some were tossed into interstellar space, while others were trapped in new gravitational pockets. The Trojans may be survivors of this chaotic chapter, testifying to the violent and ever-changing environment in which the planets we know were sculpted. Recent missions have transformed Trojan research from theory into active investigation. NASA's Lucy spacecraft is currently on a groundbreaking journey to visit several Trojan asteroids near Jupiter. This mission is the first of its kind, aiming to explore these remote and ancient worlds up close. Each encounter will reveal details about their surfaces, compositions, shapes, and internal structures. Lucy will help determine whether these Trojans formed near Jupiter or were captured from more distant regions of the solar system. Some may be rich in ices while others may be rocky or metallic. Their diversity could rewrite our understanding of how planetary materials migrated in the early solar system. The Trojans themselves vary widely. Some appear to be elongated fragments shaped by ancient collisions. Others may be contact binaries, objects formed when two smaller bodies merge slowly over time. Surface features hint at histories filled with impacts and interactions with solar radiation. Their colors and compositions differ significantly from typical main belt asteroids, suggesting that they may have originated from various regions before settling into their stable Lagrange orbits. The study of these variations offers insight into the solar system's earliest chemistry. Imagine standing on the surface of a Trojan world. The sun would appear distant and dim, casting a golden light across a rugged landscape of dust and rock. Jupiter would loom massively in the sky if the object resides in the leading or trailing swarm near its orbit. This gas giant would dominate the horizon, a swirling world of storms and clouds glowing faintly across the void. The sense of ancient stillness would be overwhelming because this surface has remained unchanged for billions of years, untouched by weather, tectonics, or erosion. Every pebble and crater would be a time capsule preserving the memory of the solar system's youth. Trojan worlds are not limited to our solar system. Astronomers suspect they may be common in planetary systems across the galaxy. Observing them around distant stars is challenging because such small objects cannot be detected directly. However, models predict that exoplanets, particularly giant ones, should be accompanied by their own Trojan populations. If these exist, they could influence the formation of moons, alter planetary migration paths, or serve as reservoirs of materials that eventually contribute to the formation of new worlds. Some theories even speculate that Trojan planets may exist worlds large enough to rival Earth or Mars, traveling in stable Lagrange orbits around distant stars. Such exotic configurations would expand the possibilities for habitable environments in the universe. The concept of Trojan planets has captivated scientists and science fiction writers. If a planet-sized body shared an orbit with another planet, both worlds could remain stable for billions of years as long as their masses and positions met the necessary criteria. In such a system, life might evolve on both worlds independently, or perhaps even develop between them through the exchange of materials delivered by impacts. The idea of two habitable planets circling a star in perfect tandem evokes visions of twin civilizations walking parallel paths through cosmic history. Although no such systems have been confirmed yet, the potential adds a layer of wonder to the ongoing search for exoplanets. Trojan worlds also highlight the dynamic nature of planetary orbits. While the Lagrange points are stable over long periods, they can still be influenced by gravitational nudges from passing objects, near resonances with other planets, or the Yarkovsky effect, a tiny push generated by the way an asteroid absorbs and emits heat. Over millions of years, these forces may shift some Trojans slightly or destabilize them entirely. Those that escape their Lagrange sanctuaries can become wandering asteroids or even potential impact hazards for planets. Despite their reputation for stability, Trojan worlds are not completely immune to the chaos of space. Another fascinating aspect of Trojans is that they may hold clues about the origins of water and organic materials on Earth. If some Trojan objects formed beyond the frost line in the early solar system, they could contain ices and carbon-rich compounds. Collisions and migrations of such bodies might have delivered essential ingredients for life to the inner planets. The study of their composition through spectroscopy already hints at complex mixtures of minerals and carbonaceous substances. Understanding these components will help unravel the puzzle of how Earth acquired its oceans and the building blocks necessary for biology. The study of Trojans also ties into the broader question of how planetary systems maintain long-term stability. The presence of large populations of objects in stable orbital configurations illustrates how gravitational forces create patterns and structures on enormous scales. These patterns reveal important truths about the architecture of the solar system. They guide scientists in determining how planets interact with debris fields and how those interactions evolve over time. For future space exploration, Trojan Worlds could serve as stepping stones for missions beyond Jupiter. They require far less energy to land on compared to moons or planets because of their small size and weak gravity. This makes them ideal targets for extracting materials, establishing science stations, or even serving as deep space refueling points. If humanity ever builds a civilization among the planets, these quiet companions might become important hubs or waypoints between major destinations. From a philosophical perspective, Trojan Worlds remind us that the universe is filled with hidden companions. Just as the planets orbit the sun, the Trojans orbit alongside them, maintaining an ancient dance that has lasted since the dawn of the solar system. Their existence illustrates how much remains undiscovered even within our own celestial neighborhood. They symbolize the many mysteries that lie quietly in the shadows of what we already know. Their motions are so synchronized with their host planets that they appear almost choreographed. They circle the sun at the same rate as their companion world, maintaining constant angular separation. As a result, they always appear to lead or follow the planet in its orbital path, forever locked in their cosmic positions. This synchrony creates a sense of unity between the planet and its Trojan companions, as if they are bound together by an ancient and unspoken agreement. As research continues, the importance of Trojan worlds becomes increasingly clear. Each discovery adds another piece to the puzzle of planetary formation. Missions like Lucy promise to revolutionize our understanding by providing direct observations that will reveal the internal structure and composition of these objects. Decades from now, humanity may know Trojans not just as distant points of light, but as detailed and familiar worlds. Even now, astronomers are uncovering new Trojans through powerful telescopes and advanced detection techniques. As surveys grow deeper and more sensitive, the catalog of known Trojans across the solar system is likely to expand dramatically. Each new discovery offers an opportunity to test theories about orbital stability, composition, and origin. Some may prove stable over billions of years, while others may turn out to be temporary captures destined to drift away eventually. Human fascination with Trojan worlds stems from their combination of subtlety and grandeur. They are small, yet significant, quiet, yet powerful, ancient, yet still holding secrets. They challenge our assumptions about what orbits a planet and how diverse those companions can be. They expand our imagination by reminding us that shared orbits are not only possible, but abundant. Trojan worlds also demonstrate how intricate the gravitational landscape of the solar system truly is. Every planet creates regions of influence, sculpting the motion of nearby objects. The Lagrange points are among the most striking examples of these gravitational features. They reveal an elegant symmetry in which forces cancel and reinforce each other in just the right way to create stability. Mathematics predicts their existence, but nature fills them with real objects, turning theory into reality. As the solar system continues to evolve over billions of years, Trojan populations may shift, disperse, or even grow. Collisions between Trojan objects could create fragments that become new Trojans or that escape into the wider solar system. Some may even find their way toward the inner planets, altering the distribution of objects that cross Earth's path. Understanding these processes is essential for predicting long-term orbital dynamics. The story of Trojan worlds is a story about companionship, motion, stability, chaos, and time. It encompasses ancient origins and future possibilities, planetary migrations and cosmic equilibrium, scientific missions and philosophical wonder. These asteroids, traveling silently at the edges of planetary influence, are reminders of how much remains hidden in the darkness between the planets. With every discovery, our picture of the solar system becomes richer, more complex, and more awe-inspiring. Trojan worlds share our orbit, share our history, and perhaps one day will share our future as humanity reaches further into space. Their presence is a quiet testament to the intricate design of celestial mechanics and the enduring beauty of the universe. They orbit with us not as rivals, but as partners in the grand cosmic journey around the sun. The Trojan regions of any planetary system are among the most peaceful refuges in the mechanics of celestial motion, yet they are also among the most mysterious. Long before humans realized that Earth even had neighbors in space, the delicate Lagrange points were already shepherding ancient rubble left behind from the creation of planets. For most of cosmic history, these bodies have remained unseen and untouched, drifting like forgotten witnesses of a time when the solar system was a violent nursery of collisions, migrations, and gravitational reshuffling. The idea that Earth might share its orbit with hidden worlds challenges everything people once assumed about the neat architecture of the planets. It implies that even the safest seeming orbital paths may host remnants of other stories waiting to be rediscovered. As astronomers expanded their search techniques, they recognized that a Trojan world is not just an asteroid orbiting near a planet. It is a gravitational partner locked into a dance that could last for billions of years. At the 60-degree points ahead and behind any planet, the combined gravitational forces of that planet and the sun create pockets of balanced motion. These pockets are not static, but dynamic. They pull drifting material into slow, swinging orbits that mimic the motion of the planet itself. This synchronized motion is why Trojans have remained stable for so long. They are not simply following the planet. They're sharing the very shape and pace of its year. When the first Jovian Trojans were discovered, scientists realized that these worlds could number in the tens of thousands. The enormity of their population raised questions about whether they might be primordial building blocks captured during Jupiter's violent formation. Their existence offered the possibility that large planets might trap and hold fragments from regions far beyond their current orbits. Some theories propose that during the early rearrangement of the solar system, Jupiter and Saturn migrated inward and outward in sweeping spirals that scattered small worlds everywhere. Many of those fragments might have been lost to space or swallowed by the sun, but others found sanctuary at the graceful gravitational centers we now call Lagrange points. As technology progressed and telescopes grew more sensitive, astronomers turned their attention to Earth's own orbit. For many years, the belief was that if any Trojan worlds existed alongside Earth, they would be very small and extremely dark, making them nearly impossible to detect from ground-based observatories. The regions where a Trojan would appear are always near the direction of the sun, drowning potential detections in intense daylight. But the difficulty of detection only made the hunt more worthwhile. If Earth shared its orbit with long-hidden companions, they could reveal new knowledge about how our planet formed, what materials contributed to its structure, and whether early collisions shaped the conditions necessary for life. Eventually, the first Earth-Trojan candidate was discovered. It moved gently across the sky with motion perfectly aligned to Earth's orbit. The world was small, but its existence proved that Earth was not alone in its gravitational corridor. Astronomers began rethinking the stability of our orbit, the distribution of early solar system debris, and the elegant gravitational mechanics that allowed such a body to remain trapped at a delicate balance point for an enormous span of time. The discovery sparked a cascade of new surveys, each one attempting to push deeper into the sunlit frontier where other Trojans might be hiding. The concept of Trojan companions is not limited to planets. Even moons can theoretically host Trojan partners. In Earth's case, the moon's influence complicates the gravitational field, but but does not make such arrangements impossible. The idea that a moon might possess a Trojan cluster introduces an even more intricate layer of orbital choreography. These possibilities demonstrate that gravitational systems can weave complex patterns that extend far beyond simple two-body orbits. Every mass in space has influence, and each influence shapes the pathways of other bodies in subtle but lasting ways. Understanding Trojan worlds is more than an astronomical curiosity. They represent some of the oldest untouched materials in the planetary system. Many may contain chemical signatures predating planetary differentiation, offering clues to the chemistry that later allowed Earth to develop oceans, continents, and an atmosphere. If future missions can reach these worlds, they may obtain samples that help researchers reconstruct the earliest periods of solar system history. Unlike asteroids in the main belt, Trojan objects have experienced comparatively fewer collisions, preserving their structure in a pristine state through epochs that transformed most other small worlds. The scientific value of these objects extends further into the realm of planetary defense. Trojan worlds share a stable orbit with their host planet. However, an external gravitational disturbance could, in theory, dislodge one of them and alter its path. Understanding how these bodies behave under changing conditions could help scientists model long-term orbital evolution and evaluate low-probability but high-impact risks. Even though Trojans are generally stable, the complex web of gravitational interactions in the solar system can occasionally reshape orbits in unexpected ways. Studying these dynamics gives insight into how rare instabilities might propagate through planetary neighborhoods. Trojan bodies are also valuable targets for future exploration missions, not only for scientific reasons, but for practical applications. Many Trojans contain water-bearing minerals and metallic components that could support long-term human activity in space. Establishing resource extraction infrastructure on a Trojan world would be challenging due to the distance and the low gravity, but not impossible for advanced robotic systems. These resource-rich regions might become stepping stones for deeper exploration of the outer planets or serve as way stations for spacecraft traveling between Earth and the outer solar system. While Earth currently has only one confirmed Trojan companion, the possibility of additional hidden worlds remains open. Advanced infrared telescopes and near-Sun survey systems are still in development, promising future breakthroughs. Some scientists suspect that several larger Trojans may exist, but remain undetected due to unfavorable angles and glare conditions. If such worlds are eventually discovered, they could reshape humanity's understanding of Earth's orbital environment and our planet's shared gravitational heritage. Trojan worlds continue to fascinate scientists because they illustrate the extraordinary complexity and beauty of gravitational motion. They remind us that the solar system is not a simple arrangement of isolated objects following predictable paths. Instead, it is a living system of interactions, influences, and histories woven together in ancient and intricate patterns. Each Trojan world is a chapter in the story of planetary evolution, a surviving witness of chaos and creation, preserved in a gravitational sanctuary that has remained stable for countless ages. The story of Trojan worlds becomes even more extraordinary when scientists begin to examine the way these objects behave over immense stretches of time. Unlike many other bodies in the solar system that wander unpredictably or slowly drift from their original positions, Trojans cling to their gravitational pockets with almost stubborn loyalty. This remarkable stability has turned them into some of the oldest witnesses in our cosmic neighborhood. Their surfaces have been shaped by billions of years of sunlight, radiation, micrometeor impacts, and thermal changes, yet their orbits have remained locked in a delicate gravitational handshake. This stability is not accidental, but is the result of a natural harmony between the sun and the planet they accompany, creating a gravitational balance that traps the object in place. When astronomers run simulations backward in time, some Trojans appear to have been in their current positions since the earliest epochs of the solar system. In this sense, each Trojan is a fossilized memory, a piece of ancient debris that never joined a planet and never drifted away, preserving in its rocky interior the same materials that floated through the protoplanetary disk before planets even formed. As telescopes improved and surveys deepened, researchers began to notice something surprising. Not all Trojans are identical. Some of them have slightly different compositions, different surface colors, or different reflective properties. This diversity suggests that Trojan worlds may have originated in entirely different regions before being captured by the gravitational wells where they now reside. One theory proposes that during the chaotic early years of the solar system, giant planets like Jupiter migrated inward and outward. Their movements could have scattered countless small bodies across interplanetary space, capturing some of them as Trojans. This means a Trojan asteroid might not simply be a leftover piece of local debris. It could be an immigrant world that traveled enormous distances, carrying unique chemical fingerprints from a region far from its current home.